Welcome. I'm Mike, a Googler, a statistician. I'm passionate about learning and sharing. Today, I'm a friend, and I welcome you into my office. We've been covering a series related to a GitHub repository of notebooks that cover end-to-end machine learning journeys. This is the start of a series. Within that, I call it the 02 series. Let's just go ahead and show the notebooks, and we'll talk about this for a moment. In the repository, all of these notebooks, we've covered environment setup. So we have an environment we can work in. If you haven't done that, you can stop here, go watch that video, or follow along the notebook directly in the repository. We've set up a data source. We've used BigQuery for that. We also have a CSV sitting in cloud storage that we might use occasionally. But most importantly, this series of 3 videos starts O2, A, B, and C. This is A. We're looking at AutoML. This is an API from Google that you can feed data and it will train a model for you. It does feature engineering. It does multiple different models. It starts picking winners as it goes. It does ensembles, and it even evaluates and creates and selects the best under a condition. And the primary condition that you give this service is how long to run. You give it a budget, an hour, 2 hours, 3 hours, and at the end of that time, the best that it's found is what it returns. Now, it can stop early if it finds that it's infeasible to continue improving. We are going to use this service in 3 different ways. Today's way is going to be through point and click console directly in Google Cloud. In the next video, we'll look at doing the exact same actions from Python using a client to orchestrate it from code. And then in the third video, we'll stay in Python, but we'll actually build a pipeline to kind of bottle up that code, make it like, I call it a people mover at the airport. It effortlessly goes through multiple steps of the process, all in one fell swoop. And all 3 of these will create the exact same outcome, and we'll look at it 3 different ways. As we get into this, I want to remind everyone what this series is about. This is about workflows for machine learning operations. These come from customers I've worked with. They come from my background. They come from friends and coworkers. Be open-minded. You might have already heard the word AutoML and maybe you're getting ready to turn the video off. I encourage you not to. I was the same way. I'm very encouraged by how simple this makes building a baseline model, if nothing else. Like something that I as a seasoned professional might want to try and beat. I find that it's very hard to beat it sometimes. So stick around. I think you'll have some fun with this one. To do this, we are going to start right here in the GitHub repository and work our way into the console and start going away and working with this. We are looking at the O2A notebook. As I was talking about that, I probably should have brought up this. Let's make it a little larger. I like this comparison chart that's in the repository where for each of the videos it shows the path it's going to take. This is the start here, no code. It's the only option I've put so far in the repository. We're going to build what's called a Vertex AI dataset. That's just a link to a data source, files in storage or a table in BigQuery. It doesn't change those. You can even update those and the link to it stays the same, but it makes it available to this AutoML service. And AutoML, here's that people mover. It does all of these pieces for me. And at the end, I can deploy it to an endpoint and get predictions. We'll even do that in this video. So back up on the video or on the notebook. We want to run that notebook, but as we know, we've already created that notebook. That notebook has screenshots. Let's go to it. Console.cloud.google.com. I will make sure I'm in my project. That was StatMike Demo 3 for the videos here. Now I'm in Demo 3. I want to go to Vertex AI. We'll go ahead and go straight to the workbench. And what we did in that 00 video, the setup, is we created this notebook instance. Let's open that. And we've already cloned the GitHub repository into this notebook instance. So we can, again, we don't need this widget that's missing. We can open up notebook O2A. And here we are. That's the exact same notebook. And this is the video that you are perhaps watching right this minute. As we go down, this visual shows, well, what services are we using? Well, we're using the notebook to review screenshots that I put out to guide a user through doing this. I didn't mark that on the chart because we're not actually going to be submitting much code within this notebook at all, other than requesting predictions at the end. We are going to start here with a data set, and it's going to link to our table in BigQuery. It could link to the table that we have in cloud storage as well. We are going to then use this AutoML tables. We have tabular data, rows and columns. We'll talk about model types in a moment. And that's going to create a model that we are going to use the prediction service to deploy it to an endpoint. And once we have that endpoint, we won't just request predictions. We'll even today dip our toes into explainable AI, and we'll request explanations and talk about what those are and how they might help us. This is just kind of a chart showing that, well, this is Vertex AI, all of these services. And this is BigQuery, our table. We're going to link to it and then kind of walk our way down the tree in Vertex using different services. All right. Scrolling on down. Step one is to build a data set. We're going to go to datasets. We are going to create data set. And we're going to call it O2A after the video. And we're going to talk about it once we're over there. Let's get into here. I'm clicking datasets. This is what I kind of imagine a business user. They're used to BigQuery. From BigQuery, you can actually run AutoML. That'll be the O3 series of videos. So kind of hold that thought. But I'm in Vertex. I know my data source is in BigQuery. I've even prepared it for analysis back in the O1 video. I put a splits column in, so I've got indicators for each row being part of the training data, the testing data, the validation data. I just want to link to it. So create data set. For names, I like to associate it with the notebook, kind of helps me keep track of things. I get different choices for types of model. Let's talk about that. AutoML, we're using it for a table, a tabular data set. Let's click that. That means it has rows and columns. Columns are features or the target or other stuff that we might omit. Rows are transactions or observations of people or things. In our case, they're transactions on credit cards. When you have that type of data, you then start thinking, well, for AutoML, ML, this is going to be supervised learning. We're going to be trying to predict one of those columns. That means the columns will be one of two types of things: classes, kind of categories of things, or numeric, where it's maybe a range, like it's predicting lifespan or age or amount or count, balances or size. In our case, we do have that classification when we're going fraud, not fraud. You could also have forecasting as an option here, and that's still on that end of kind of the regression problem. I have a numeric scale, but I have these groups of rows that have this natural ordering of time. Maybe it's weekly, daily, monthly, yearly, quarterly, and those rows within those little compartments, form a time series. And I'm trying to say, well, what's the next time point, and then the next one, and then the next one. So I'm kind of forecasting over a movement that's happening in this time space. All right, this is also available for text data. You can do several different types of models. You can classify text by a single label. Is this a faxed document for a particular tax form? You can give it multiple labels. It's a tax form for the US. 2 labels maybe. I can extract entities. Pieces of text that describe the content of the document from the document. Or I could even, this is very popular like call centers and things, take the text snippet and say, is it positive or negative? Is the person happy or unhappy? And then act on that information. Similarly, from images, I could classify it as one or multiple things in the image. Is this cats or not? Is it cats, dogs or not? Two types of cats, two types of dogs. I could detect the objects in the image and it'll give me the bounding boxes, like XY positions of where they're at if they're in the image. And I could even segment images. And then video, those are like moving images. So you start thinking of a lot of those same things from images, but tracking them over the time part of the video. Grabbing an action in a video, saying, hey, this segment has sports. This segment has a person talking. And that would be even classifying a single frame or a segment or an entire video as, hey, this is a vlog. Hey, this is a sporting event. Hey, this is school play. Back to tabular. Let's stick with this today. We are going to hit create. And it's going to ask us a couple of questions. Now, if we're following along in the screenshots over here, it's going to next talk to us about what type of data. It says, hey, you've created it. What is the source? Well, my source can be a local file on this computer. It's going to upload it. It can be a CSV sitting over in cloud storage, or in our case, it is a table from BigQuery. And we already know where our table is over there. It's in a project called StatMike Demo 3. And the next level is our data set, which is fraud. And our third level is fraud _ prepped. As I filled that in, it kind of identified it. I'm going to hit continue on this. Come back over here and say, what do we expect next? It's going to kind of give us descriptive information about that table. Again, it's not moving it into Vertex. It's literally linking to it. Why is that important? Well, if 10 minutes from now somebody adds records to that table in BigQuery, this link to that table is living. So once I trigger the training job, it'll grab a snapshot of it that moment. So I don't have to think about the orchestration of don't create the data set until the table's ready. No, it's just a link. You're good. It shows me the URI to BigQuery for that table. Shows me my columns. I could generate statistics and see like % missing and distinct values in columns. At this point, I've created a data set. I can literally come back here, create data sets, and I see, hey, here's one right here. I can click into it, and that's where I see that information. We now want to train an AutoML model. There's two ways to get to this. I'm going to show both. Let's go back here and look at that. We are going to, first in the data set, I could go over in the margin here and say train new model. I could come down to training, and I could create a new training job on a data set. Now there's only one data set, so it pre-filled that for me. O2A, I know my classification, we talked about that a bit. My objective is to classify this as fraud or not fraud. That's stored in a column called class. I do have the option to pick custom training. If I've built this, that'll be a future video. I want to use Google's AutoML today. Hit continue. Model details, notice it's time-stamped the data set name. That's very cool because if I rerun this again tomorrow, updated data, it'll distinguish between those. I need to tell it which column it's using to train this classification model. Click here and it lists all the columns. I want that class column. And under advanced, data split. Now we talked about this in the 01 video, a lot of services, even at the point of custom training, I could choose to segment my data into these partitions. A good chunk for training, a holdout for testing, a piece for validation. We've already done that, and we want to use manual here, which means we have to tell it which column. We called that splits. That'll automatically be excluded from training, but used to pick the portion that's used for training. We can hit continue now. And this lists all of our columns of data. Now, it would be okay to just say, oh, looks good to me, but we could manipulate how the data is represented to AutoML here. Now, AutoML is going to do feature engineering. It's going to do one-hot encoding, like taking categorical features and turning them into multiple columns of ones and zeros. It's going to standardize numeric columns, so all of these floats, it's probably going to subtract the mean and divide by the standard deviation type of thing. It's automatically doing it now, but I do have some ability to say, I know you think that's a float. I want you to treat it as a category. Maybe it only has two float values, 1.2 and 1.8. I could kind of force that if I wanted. I'm not going to do that because that's not our case here. Our time variable, it does happen to be an integer. It's not a time, so I could tell it timestamp if I knew it really was. It's not. It's number of seconds since a date in our case. I do have transaction ID. That is non-informative to a model. It could actually leak information to the model training, and that the model might just learn particular transactions are fraudulent. Well, that's useless because that transaction ID is never going to happen again in the future. So that doesn't help me. So I really want to go over here and say exclude transaction ID from training. Any advanced options down here? Yes. This is one where a Q&A has come in, and we should talk about this a little bit. So let's go to our Q&A session, and let's hear this question.
Hi, Mike. What optimization objective should I choose?
Back in the O1 video, when we loaded this data, we looked at the distribution of this target column class. How many were fraudulent? How many were not fraudulent? It's exactly what you expect. Only a few, 400 or so, are fraudulent. Nearly 250,000 are not fraudulent. I mean, that mimics the real world. I mean, this is a real world data set. Not very many transactions are fraudulent. The magic is being able to pick out the few that are and kind of stop them before money exchanges hands to the wrong people. When you have a model, no matter what type it is, whether it's the regression type or the classification type, what you're optimizing. This is a whole other video. I talked in intro video about learning ML. Let's dive into that just a little bit. You're going to have this function, and it's going to have a cost function, this loss function, and you're trying to minimize the bad by learning. And you can choose how you optimize what is being learned. The default for a binary classification, two classes, fraud, not fraud, positive fraud, negative, not fraud. And the default for that would probably be the area under the ROC curve. Very brief description of what an ROC curve is it's this y coordinate being, I always have to think through this because I mix it up with the precision recall curve we'll talk about in a second. The ROC curve, you have true positive rate. So high true positive means, hey, if it is fraud, I showed you it was fraud. And the x-axis is false positive, meaning, hey, it wasn't fraud, but I told you it was fraud. Well, you want to be low false positive and high true positive. If you didn't care, if you just wanted to be right about identifying fraud, it would be very easy to just mark everything as positive fraud. Of course, you'd be wrong 99% of the time. All of those not fraud cases would be labeled fraud. That would be a completely useless and unhelpful model. When you have multiple classes, maybe you have fraud, potential fraud, not fraud. I'm not sure that makes sense, but let's just pretend for a moment. Maybe you're categorizing sizes small, medium, and large in a different model. Instead of doing that area under the receiver operating curve, you would use log loss. That's a way of kind of averaging through the multiple categories being reconciled. In our case, we know something. It is binary, but it's highly imbalanced. And for that, we should choose area under the PRC, precision recall curve. Now this is a different curve. In this case, the precision side of this is the ability for a model to talk about positives. So think about this: true positive divided by all predicted positives. So that's true positives and also those false positives. So it's the rate of how many of the ones projected to be positive were actually positive out of them. So that's precision, the ability to label a positive correctly, to label fraud correctly. And then the x-axis is recall. It's a nuance. It's not really nuance. It's a detail that's a little bit different. It's true positive divided by true positive plus false negative. That means it's hopefully 1. True positive over true positive. But whenever you accidentally label a positive one negative, you failed to recall that one was positive. So it lowers that. This is a better objective to optimize for this particular model we're looking at. Now, the last two down here that were on the screen is if you're in a critical situation, fraud could be one of those. Maybe you think clinical trials, my background, where maybe precision is the most important thing in the world. And you could say you want to optimize recall at a particular precision. So you could fix precision and say optimize recall. Or maybe it's the other way. Maybe recall is very important and you want to fix precision, or you want to optimize precision at a specific recall. So you can fix, I won't allow more recall error than this, maybe set it at 0.95, and then you optimize precision against that. Today, we're going to pick area under the curve for the precision recall curve. We should do a whole other video on this. This is definitely the part that gets confusing. When we evaluate our model, we're going to look at a lot of this information, and that's going to be the fun part of the video. Let's hit continue and jump back to our screen share. The next thing it asked me, and what I forgot to show, was down here at the bottom. I picked area under the curve, PRC. Weight columns is another question that gets asked. Sometimes you store data by, hey, this observation actually happened 100 times in my data, or maybe you're trying to weight a row as being more important because the customer is more important. Maybe that's a case for this. In our case, we don't have any weighting, but you could imagine data sets where that is the case. Each row has a column that says it occurs 100 times in the data. Well, you'd want to weight that to show that relativeness. Or if you want transactions related to high dollar accounts to mean more, you would pick a column that represents like account balance as part of your weighting. All right, hitting continue. We need to set a budget. This is the only parameter for AutoML you get to control. Like how long is it going to try before it returns a result? If you look into the pricing guide or into the manuals for AutoML, it'll give you a general guidance. Under 100,000 rows or 1,000,000 rows, I think it says like an hour to 3 hours. We're going to give it 1 for our demo. I've looked ahead, it gets a pretty good model. And we're going to hit start training. Now, this is the part where this is going to run for an hour, at least an hour. Actually, it'll run a little more than an hour because it spends an hour training. But there's also the part of getting the data in and reconciling at the end, and that gets tacked on. So it might be a little more than an hour. We'll come back. We'll take a look at where we're at that point. For now, let's put the title screen up and just take a little pause, and I will put on the screen how long we waited before it was ready and then come back. And through the magic of the pause button, we are now back. Let's take a look at our progress over here. We see that the O2A model, we can ignore O, B, and C. Yes, I recorded those videos at the same time. The O2A training pipeline that we created has now completed running. It ran for 2 hours and 16 minutes. We gave it a budget of 1 hour. We'll talk a little bit about why it's longer. We have two choices. we can click in here, we can go down to models. Let's see what our guide tells us to do, the notebook on GitHub. As we scroll through here, it shows the next thing to do is, let's see, we're under training. We click one of those models, or we select the models tab and we can click the model, and then we'll get to evaluate it. So let's go in and do that. So here we are in the console. I'm going to click the O2A model. And notice that it takes us down to the model section of Vertex AI, and it immediately opens up what I think is just the coolest part of AutoML through the console. This is the part where in B and C, we can also see them here, but when you get to custom training, you pick your tools for evaluating the outcome. Here, a bunch of tools are just provided to you by default. We've done a classification model. We chose the optimization method of area under the precision recall curve, and it immediately shows us. Here's the labels that are being classified, 0 and 1, 0 not fraud, 1 fraud. It shows us all of our metrics for evaluating this model at different confidence thresholds, and this is going to be interactive. We see that the precision overall is 99.9. The recall is 99.9. Let's not be fooled by that. I'm going to call this a good model, not a great model, and we'll talk about why. Confusion matrix. I like to start here. It just gives me an overall ability to see how well things are being classified. I don't like percentages when I first look at these. That's why I love this little slider toggle over here where I can turn it to counts. And one reason why is we know there's an imbalance. There's a lot more zeros not fraud than there are fraud. Of the zeros not fraud, all but 3 are correctly being classified as not fraud. So you only false alarm 3 times. That's a false positive. That's pretty good, I feel. Now, in the positives fraud, you miss 16 of them, but there's not that many in the training data. You get 37 of them correctly. To me, that's a good start. It's probably even good enough to use since we're not accidentally alarming too much. But while this model might be being used, I would probably be at work trying to make it better. That's my opinion. Just kind of projecting into the fraud world. You always want, of course, to get all the zeros right and all the ones right. That would be the ultimate. If we go into that practice of trying to make the model better, another cool thing is it immediately shows us which features were most important to the predictions. That's really neat. We see that V14, now if we had that original data, we could kind of look at those principal components and see which variables are loading highly on V14, and we would know, hey, even in the original data, these variables are probably very, very important, these features, to this particular prediction. Same with V10 and V4 and 12. Interestingly, the amount of the transaction isn't all that important. I would kind of go, there's probably some work to be done in understanding amount. Maybe it's not the amount. Maybe there's a threshold like giant amounts or lots of little amounts on the same account. That starts to get into information between rows. You might need to do some more feature engineering pre-modeling where you start to bring in data like this is transaction 1 of 50 today, or number 10 of 400 today. Lots of transactions, lots of small transactions. Again, we're just kind of going into how to improve a model in our mind. Let's go back into evaluating. What I love about this is it assumes the default threshold first, which confidence threshold is that ability or that cutoff where you say, okay, if it has this much confidence that something is a label positive, then call it a positive. And usually you start with the tipping point and the probability scale of 0.5. If it's greater than half, then it's probably that. If you wanted to increase precision, you would make confidence higher. Now that's going to come at the cost of, you want to make sure when you call something a positive, it really is a positive. Well, you're gonna make more mistakes in the other direction. You're gonna make more false negatives if you do this. Because you're going to fail to call some things positive because you didn't have enough confidence to do that. And then if you tip it in the other direction, make it easier to call it a positive, well, that's going to make recall easier, but it's going to make precision lower. So that's that balancing act that you can play. And it updates our precision and recall scores to do that. So if we see we bottom it out, we get perfect recall and pretty bad precision. And if we top it out in the other direction, we get horrible recall and amazing precision. These are just great tools. I love the interactivity of this and the ability to just diagnose. And again, this is a good model. I would probably go to work making it better. We'll do that when we get to the custom training. What would our next step be? Well, we want to put this model into production so that, hey, new transactions go against this model and get classified as fraud or not fraud, so you can intercept them and say, stop this transaction, it looks like fraud. This model is good enough to do that. How would we do that? Well, we can come up here and look at these additional tabs. Model properties, what does that tell us? Oh, this is great. It tells us, yeah, we gave it a 1 hour budget. It spent 2 hours and 16 minutes training. And remember, there's more than just training. There's preparing for training, and there's productionalizing the model that it finishes with. So there's some added tax in there. We have names. We see the optimized for. These are all the options we picked when we ran it. Deploy and test. Let's go to our guide. I'm pretty sure that's where we go next, but let's just check. Models. And we've clicked the deploy and test, and we are going to deploy to an endpoint. Let's do that. Let's talk about what it is as we do it. An endpoint is basically like a web address that you can send a request to, which would be like a new transaction, all the features in a row. And then it would run it through this model and return back that predicted value of the target. We need to do two things. We need to, one, have an infrastructure that can host that web endpoint. Then we need the software behind it, the container that has the runtime for the model and the actual logic of this specific model, the architecture of it, to interpret that input and create the output. And the way we do that through this point and click end-to-end version is we just say deploy to endpoint. This is the great part about Vertex. It makes this part easy. We don't have to think about a lot of infrastructure setup and things. Click deploy to endpoint. Now it knows what computing parts needed for an AutoML model. I just have to give it things like a name. We love using the name of the notebook that's creating it in this project. Want to use the same. Why would I choose a standard over a private? Private, maybe your application is like within, let's see, these are credit card transactions. You're within a bank. And an internal application is sending these requests and back. So you could do it all within your VPC private, and it might even be a faster response time. But standard would be kind of open to the web. You can use REST, in our case Python. I'll show all of these, REST and Python, to get that prediction back from there. Let's hit continue, or what other advanced options? All right. At an endpoint, you can actually have a model hosted, but you could actually have another model and another, and you can have this thing called a traffic split, which says, hey, I have new predictions, we'll route what percentage of them to which model. This is our first model at a new endpoint. So we want to put 100% of the traffic to this model. But when I make a better model, I might put it out there and at first put 10, 20% of the traffic against it, make sure it's working well, and then ramp it up to 100% and take the old model away. That's a great way to ease a model in production and just make sure things aren't crazy. Explanations that we're going to talk about at the end of this video are going to make it even cooler to see how we might trust a model in production. New data coming against things always makes us feel like there could be exceptions. There could be weird things that happen. All right, so 100% traffic split. We're going to do one compute node. This is an example, but if you wanted this to scale for more requests and be able to handle lots of simultaneous requests, you could say 2, 3, 4. You can give it a max so it never exceeds a value. Compute type, let's actually lower that down to a 4. And do I want to enable logging? That would be kind of cool if I were trying to trigger things. I could use cloud logging to see signals and trigger events. And explainability, by default, this has feature attributions turned on. We're going to talk more about that later, but remember that piece. Let's hit continue. Model monitoring, we could enable monitoring, and this is awesome. We're going to talk about this in future videos that focus on monitoring, but this is that ability to say, hey, let's look at new data that's coming in and say, is the data different than the data this model was trained on? And hey, let's look at new predictions and say, hey, are these not as good or different than what we originally got from our trained model when we trained it? Those shifts and drifts are good triggers to say it's time to retrain. And it gives you a confidence in the model that's in production still being good, or is it stale and needing refreshing? We won't worry about that for today. Let's hit deploy. This is another one of those points where creating an endpoint is pretty quick. Putting that model into the endpoint, deploying it is going to take a little bit of time, 5 or 6 minutes. So I'm going to go back to the title screen and pause this video, and we'll come back and pick up there. And we are back. It has been 14 minutes and our model is ready. Let's take a look. So as we look at this screen, we see now that under deploy and test still, the model O2A has a new deployed ID. That way, if you update that model and you redeploy it, it would always have a uniqueness to it. It is in a status of active and monitoring disabled. We didn't pick that. A couple of options on the screen. One, we could also use this. We could edge optimize model. We could export this model to use somewhere else. Perhaps we built this in Google Cloud, but our application that does fraud, that receives those transactions, is in a server that's in our in-house data center. We could extract this model and bring it over there to use. In our case, in Google Cloud, we have an endpoint, we have our model to it. We want to send new requests to it and get predictions. That happens in one of two ways. You do it online, meaning an application somewhere that's receiving the new transaction, packages and shapes that and then sends it in and immediately gets a response back. Or you could do it in batch, where you take a whole bunch of new records. Maybe every night or every hour you take new transactions and you ship those over and get predictions back, and maybe store them even where the data originates, in our case, BigQuery. We're going to look at both of those. Right in the interface here, they give you the ability to test your model. They give each of the features and the types and whether it's required. They're all required because we used them to train. They fill in some starting values, and you can click predict. And what's going to happen when you do that is you'll get a prediction result. It'll say, hey, the selected value for this is 0, meaning not fraud. It gives two very interesting pieces of information: a baseline prediction value and a confidence score. It's very certain, almost 92% here, that this is a 0, not a 1, that it really believes that this is not fraud. We know that V14 was very important to detecting fraud, so we could actually kind of gamify this interface. We come to V14 and let's just remove that 0 in the decimal and make this 10 times more important and hit predict again. It still believes strongly that this is a 0. Again, this is just kind of like a little experiment. I don't know that we can make it a 1, but we'll try. Let's try putting an extra 0 in, 10 times smaller perhaps. Hit predict on that. No, we haven't been able to gamify it. There's a better way to do this. That's what we're going to do next. And that is use this model for predictions. Now, you're not going to do predictions from the console unless it's that batch. You can schedule that. We'll come back and do that. There's a tab for it right here, batch. Let's go back to our notebook. Let's scroll past the screenshots, and let's now pretend like we're the application developer who's going to, integrate fraud detection into the application. And today, we're a Python developer. We're using a Jupyter notebook. We're going to use some code. I need to change this. Now, I said this was end-to-end no code. This part, we're kind of switching personas into using the model built by the no code interface in an application where there is code. We need to change our project ID here to the one we picked, StatMike Demo 3, or whatever you picked. The rest of these can stay the same. We're going to load the package AI platform that allows us to interact with Vertex AI. The rest of these are about shaping and formatting data for exchange with the endpoint. We're going to set up a client to get to the Vertex AI endpoint. And go ahead and initialize two things, and that is the project ID and the region. And we'll also set up a client for BigQuery so we can pull data from over there. We need to grab some examples. I don't want to do the hunt and peck that we did in the interface trying to trick it. We're just going to pull original values and send those over and get their information. I like to store data locally, and since there's lots of notebooks, this is a variable that defines a subfolder that will hold that for us. And now we're going to create that subfolder if it doesn't already exist. Now we see O2A here. Let's go into there. It's empty currently. What this next field does is it says, hey, let's make a data frame, pandas. That's a Python thing. And let's go to BigQuery through the client, and let's query the original table and pull back some records. I limit it to 10 records, and we'll grab test records. Those were the ones that weren't involved in the training. So we can hit that. We could even, if we wanted to really play around, we could put a where statement, an and class equals 1, and only retrieve records that are fraud and use those to see it rather than trying to manually figure out a good combination. Let's take a look at a couple of those. And what we see is here's values for all of those feature columns. Here's values for class and amount. We have these extra columns, splits and transaction ID. Those aren't in the model. Remember, we excluded transaction ID. Splits is only used to do the splitting of the training data versus the validation and the test. We only need the rest of these columns. So this next row of code here basically reformulates the predictions here to take away those and take away the class. We're asking the endpoint to predict class. We don't want to give it the correct one. So this is doing that. All right, and let's create these and then take a look at them. I'm going to insert a piece of code here. I'm going to pass two things to the endpoint, instances and values. What are instances? You can study this code, but it is essentially a struct dictionary-like JSON blob thing that has the fields in key value pairs. So a field with key amount has value 0. A field with key time has value 7148. A field with v1 has this value. This is the structure of the package of that request. So as an app developer, we're essentially making the communication protocol. We've got the new transaction. We're shaping it so the endpoint can interpret it very easily. And that's what this part is. Now we're going to send that over to the endpoint. We could also look at parameters. And there's nothing in that one. So now endpoint, we're going to go over. We want to pick the endpoint with the same name as this notebook. Again, that's why I use those handy names, as it makes it easy for me to do this across these videos. Then we're going to create a prediction where we go to that endpoint, ask for prediction, give it the instances and the parameters. And very, very quickly, less than a second there, we got back the model's telling us, hey, I know about classes 0 and 1. The scores for those classes are 0.91 for a 0, 0.08 for a 1. It believes strongly that this is not fraud. In the deploy model ID, And you did not ask for explanations, so I didn't give those to you. We'll talk about explanations here in 1 second. Now this was using Python. There are other ways to ask for predictions. There are other clients. The most native, low-level one that you probably would use in an application development is REST. So I wanted to demonstrate using that one. Here we're going to format a file of JSON, that same thing we provided as instances before. It even basically dumps instances into a JSON file. Notice that's going to populate in our folder right here. We can even open it, take a look at it, expand it, and we see that it's just a great representation of all that same information for prediction request. And we're going to do a curl command. This exclamation from Python Jupyter Notebook just says, hey, go down to the command line and do this. And post, we're going to send it authorization for the endpoint by grabbing that using the gcloud command from our environment. We're going to pass it that JSON file, and we're going to tell it where to go. Well, our address to get to the endpoint. We have the endpoint name from above, and that gets inserted in here. We know the region, so all the information we need, we construct that. We run it very quickly. It comes back in a little bit different format, but the exact same info as above. It says, hey, I believe that is a 0 with 0.91 probability, and it is a 1 with 0.08. So you would, if your threshold were 0.5 or even 0.918, you would classify this as a 0. Deployed model ID, model, that's great. It even tells you the model at the deployed model ID, so you can get back to the original model and the display name of it. Another way you may do this, if you're in Google Cloud, a lot of people use the shell there, and they get down and they use the gcloud command, or maybe you have that set up locally and you're authenticated against your Google Cloud environment. You can also use gcloud to go to AI and ask for endpoints and predict and provide all the same info, that request.json file we made for the rest above. And we do that. Its response looks like this, just a nice little dictionary of classes and then scores for those classes. And you could say, well, the highest score is the first one, and that is a 0. That's the beauty of all of this, is we've never worried about infrastructure and things. We just set some parameters in the console, we deployed it, and we've interacted with it from 3 different application-like interfaces, and we've gotten predictions for a record. These endpoints for AutoML models automatically, well, we left the box checked, come with explanations. And this is an exciting bonus of this section. You can do this for custom models too. We're going to cover that. But explanations give us the ability to understand this prediction and what impacted it versus, say, the typical prediction. If we go back to that same endpoint, and instead of saying predict, we say explain, we get explanations. Let's do that. And we do that, the explanation comes back, it includes the prediction. Now that's the same. There's no reason for it to be different. It's the same model, the same inputs, the same prediction back. But within that explanation, there's additional information. And this is a good chance for us to first briefly do a Q&A and talk about explanations.
Hi, Mike. What are explanations?
Explanations are this really crafty concept of basically being able to interpret a model. Now, my background, statistician, going to school in the 90s, I heavily spent most of my time in learning inferential statistics, like interpreting parameters with things like confidence intervals, the dreaded p-value. That's not what this series is about. And interpreting the impact of slopes and interactions to the outcome of models. Neural nets, so many parameters that you could drive yourself crazy, and you also lose statistical confidence in all that information by trying to do it that way. So there's this idea of, well, let's create a typical prediction. Let's take the middle value, we'll start with that word, middle value for every feature, and create a prediction. Now, what's a good middle value? For numeric values, they pick the median, the middle. So rank all the values that it saw in training and take the middle one. That's better than the mean because the mean's not always in the middle. It can be skewed by high values or low values and extreme values. So the middle value. And if it's a categorical variable, take the mode, the most frequent value. If you were to draw a histogram, it'd be that tallest bar. And plug those in and get a nice baseline prediction. Now, if you were to take the current prediction and input it into the model, each feature had an impact on making it higher or lower than that baseline prediction. So you can see the impact of the current prediction, even though you may be asking it to predict something that it never saw in training. You can get the impact of each variable on creating that prediction. And that can be very important because since it can see a value that it never saw before, it might actually help you diagnose that, there's an area where you shouldn't do predictions. If a feature exceeds a specific value, you discover something about your model. That's why I love explanations. Is they're a little less rigorous, but they're very easy to interpret and very easy to help diagnose, and even do things like maybe you're predicting something like that's very important to a person, like their credit score. Well, if it comes out that it gives them a bad value or a lower value than they expected, you might want to tell them what caused that. And you could say, well, these features, number of accounts open was very important to this prediction and it's low. That gives them an actionable piece of information they can try to impact. Explanations are great for this. So let's go back to our screen and let's look at our explanations. I've written a little bit of code to print out pieces of that response. We're going to do that. And what we see is that baseline output for this model is a 0.9182, about 91. This particular instance that we've predicted is almost the same. It's just a little bit smaller. That's probably not the most ideal example, but let's roll with it. Let's take a look at it. It predicts it to be a 0. In this next section, what I'm going to do is I'm going to go to that explanation endpoint and I'm going to go get the attribution for every feature. And rather than printing them out, since we had 20 some odd features in our model, we're going to graph that attribution, that difference caused by that feature from the baseline to the actual prediction. Those differences sum to the delta. They'll sum to that tiny difference between baseline and instance. But when we graph it, we get a nice picture that says, hey, this particular prediction was heavily made a little bit higher by V14 and V17, but that wasn't enough to overcome by how much lower V4 made it. So if we knew that V4 was something like number of open accounts or number of transactions in the last hour on that account, that would give us actual information about why this prediction is what it is. That is an amazing thing that we just got by not even doing anything but other than not selecting unselecting a checkbox. It's available for you to just ask for from the endpoint at any time. The one thing left in this particular video is what if we wanted to do a batch of predictions. Batch is what it sounds like. Maybe you've collected transactions for the last hour or day and you want to run them all through the algorithm kind of offline at night or in the background. Well, let's make a job that does exactly that. And since this is our end-to-end no-code version for the 02 series, we're going to go back to our console and we're going to create our batch from this interface without code. Handily under models, there is a batch predictions tab. Is that what I used in the guide? Let's actually scroll back up to our screenshots and see how we did it. We actually went to the batch predictions interface. So there's multiple ways to get there. If you're under the model, we could of course click batch predictions and then create a new one. We could also go down here to batch predictions in Vertex AI and say create, and this is going to make us pick our model. So let's fill in this information to create this prediction job. We want to give it a name. We like the notebook name, keeps our assets separated. Let's make sure to pick the correct model. We want our source table to be from BigQuery. The project is the same one we've been using throughout these videos. The dataset fraud with table, we have a choice. We could use the original fraud or the fraud prepped. Since we're scoring, we don't need those prepped columns like split or transaction ID. So we could just use the original fraud. I don't know, we might want to compare it by transaction ID. So let's use prepped. Output, let's store that in BigQuery and let's put it in the same project, even in the same data set. Let's generate feature importance and the explanations for each of these. Now, when we click create, this is going to create a job here. Our screenshots are going to show us what this does. And so that we can end this already pretty long video, this is going to help us out a little bit here. When we create the batch job, we fill this in, it's going to finish running and put a check mark by it. Now, when you click into that batch job, once it's complete, you're going to get a little bit of additional information. You're going to get what model was used, what was its import location. That was BigQuery. This was when I ran it, prepping the notebooks for GitHub. It tells you the total number of items predicted, so it predicted everything. The date, how long it took to create, and this is why we're going to take a little break from the video today. 7 hours that it did for this one. Status, completed without errors, and export location. It dropped it into the BigQuery project we talked about, and if you click that link, we see it creates a new table with the prefix predictions, and it has all the information for that. With that, it's time for one more Q&A. Let's take a look at this one.
Why and when should I use the console to create a model with AutoML?
This is a good question. I mean, I'm a coder. I like tinkering and doing things very custom. So one, just the choice of AutoML is already like, well, this is a good baseline model. And we found this is a very good baseline model. I did see areas where I hope to make this better. What was awesome about this is I was able to do this where I might not have been able to fit it in my daily schedule. I could just go to the console, and whether that data set is sitting in cloud storage or in BigQuery, whatever format, I could immediately trigger this to run, maybe go away while the AutoML is training. It would send me an email letting me know it's done. I could come back, and without any code or plugging in any tools or anything, I could just click, and in a screen I get evaluation metrics, and I can start to evaluate the quality of this model immediately. This is an amazing business tool, an amazing way to just kind of accelerate side projects or initiate projects that you would then take forward in other areas. Now, if you need to build lots of models, this isn't going to be efficient or fun. You could still do something very similar. Watch the next video and see where from Python I trigger all of these things. And you can imagine a loop where you're triggering multiple AutoML training jobs for different segments of data or different data sets. You can even think about automating this in the next video, 2C, where we package up that whole process from data to train to endpoint and deploy into a pipeline that's very easy to repeat and reuse. I very much thank you for the time today. Let me remind you, if you enjoyed this video, clicking that like button, it kind of is like a pat on the back. It makes me feel good. If you want more videos like this, hit the subscribe button. It lets me know people are waiting on stuff like this. And if you hit the bell, you'll be alerted when I do create more. If you got use from this in any way, just drop some comment down in the comment section of the YouTube video here to let others know. It encourages them that this might be worth watching. That's how I evaluate. When I look at a video that's longer than 5 minutes, I first look at the comments and make sure people are actually liking it and worth their time. And this one's definitely a long one. And then finally, the most important, if you have ideas for maybe this triggered a different workflow you're thinking about, is it possible, or I would like to see. Maybe you saw things I did that you think I could have done better and you want to give me feedback, or maybe you saw errors I did and you want to give me corrections. All of those are great GitHub issues. Just go to this GitHub repository. If you got to the video first, the link to GitHub is in the description. Hit issues, mention this particular notebook, O2A, and then give a comment or one of those items, and we'll start interacting, and we can update that very quickly, much faster than I could recreate this video. With that, thank you for your time and your feedback. Let's work together to make the practice of AI and ML more collaborative, accurate, and approachable to a wider and well-connected audience. Thank you. Have a great day.